Let's look at 31. Suppose a random sample of 50 bottles of cough medicine are selected and the alcohol content is determined. Let mu denote the average alcohol contained for the population of all bottles of the brand under the study. Suppose the sample mean is 8.2 grams with a standard deviation of 1.5 grams. Find the 95% confidence interval for the mean alcohol content of the cough medicine. Report the margin of error and show all work. We're going to do this two ways. We're going to do it by hand so you get the idea, and we'll go back and use the calculator. You're going to like the calculator. The calculator is going to be a lot easier. Remember, margin of error is statistic plus or minus your critical value multiplied by the standard deviation. Right? What's our statistic in this case? What's our guess? Look back at the problem. Everybody okay with where I got 8.2? So the guess my guess is based on that sample, plus or minus. Critical value. They told me that I'm 95% confident. How am I going to get T-star from that? Remember how we got T-star in the past? Inverse T. So we're going to go to our calculator, and we're going to go, very good to me, we're going to go to distributions, and we're going to go to inverse T. And I have this left up here from earlier. Is everybody okay with why I did 1 minus 0.95 divided by 2? Because it's a confidence interval, and we've got to share that 5% equally on both sides. Degree of freedom, n minus 1. And I got 2.01. Let's talk about the standard deviation for a little bit. Should we leave it 1.5, or do we need to divide it by the square root again? What do we think? What do you think, Ray? And why? I think you do. A lot of it has to do with the way it's worded, but if the mean is 8.2 and a standard deviation of 1.5, let's see what happens if we divide it by the square root of 50. I get 8.2 plus or minus. This piece is called my margin of error, and when I crunched those numbers, when I did 2.01, that quantity, I got this. And I could leave it like this, or it ended up being
so we do have to divide it.
I think we do because of our sample size. I think we need to. But let's check it on the calculator. Do y'all remember where to go? It's a T interval because we don't know the population standard deviation. So we're going to go to stat, test. We want a t-test. And I'll leave that up here since I already have the values in there for you. get 7.77 and 8.62 when you run down. Okay, anybody need help with that in your calculator? Explain in words what a confidence interval means. So let's just explain what this means. And I just said, are y'all remembering this sentence? We are 95% confident. That the interval captures the true mean, and true mean that will hit that population mean, or you can say the true population mean, either one. But what if I not? What if I got to finish out with it? I've got to do context. So we're 95% confident that that interval captures the true mean alcohol content, true mean alcohol content. Oh, and I forgot something else. I forgot to say it. Does anybody know what we did to put in? What 2 words did we? Yeah, I think, because I think it won't hurt to put it in, and you don't want them to think that we think every bottle we pick up, let's see, we're 95% confident that interval captures the true mean alcohol content on average. We might keep it by without it, but probably okay leaving it in too. So the next question says, would 90%, so we get 95%, what if we went down to a 90% confidence? What would happen to my interval? Do I? So if I'm less confident, and what's your thinking on that?
Less confident. Less spread.
You're like me, I think backwards every time. So 90% confidence interval. Does that make sense? And I want to explain it to you the way she explained it to us Saturday. It helped me because I always think backwards. In your mind right now, don't say anything out loud. But every one of you, I want you to guess my age. Okay, stop. Connor. Okay. So what if I said, how confident are you that you got within 10 years? Put a number with that, 10 years. Yeah, I mean, if you know say anything about me, because I've said it several times, but probably. Okay, how confident are you that you got within 5 years? See how my interval's getting smaller and what's happening to your confidence level, okay? How confident are you that you got within 1 year? Okay, so this is really small. We started out at 10 years. What was your confidence level at 10 years? 100%? Okay, what was it at 5 years? Okay, so more, okay, and then what about 1 year? So that helps, and whenever I get turned around, that's kind of what I think through, because I do have a tendency to say it backwards. So I really did like that. That helped me a lot. Okay, so now D says the manufacturer claims that the content is 8 grams per bottle. Let's test that. Okay, so that sounds like a test to me. So we're going to run through state, plan, do, conclude for a t-test. So state. What do you need under the state for a test? Need hoe and haw? My hoe is that the mean is 8. Haw is, and they didn't say They didn't say anything to lead me to believe that it should be anything other than not 80. We could have done less than or greater than, but it just said, since we're just testing the point. So far, so good? Alright, now let's plan. You gotta write what test you're doing, and then you have to check your conditions. We can send here and be in pretty good shape. We're gonna do simple random sample, and I think we can go ahead and say stated. I can really do that. Okay. Anybody remember what the I stands for? Good. And here we can we're gonna check the 10% condition. We're gonna do 10 times 50, which is 500. It's reasonable that there are more than 500 bottles in the population, so we can check that condition. And then we also need to check the normality condition. For normality, you're looking at what theorem to back your case? Beautiful. And what's that magic number? Okay. So our 50 is greater than 30, so by central limit theorem, now, don't try the central limit theorem with chi-square or anything like that. That's a different ballgame. But for means, that's where you need to go. So state, plan. Under the do piece, let's put our p-value and our degree of freedom, and then we'll conclude it. So we'll go back to the screen that I was actually in before. You go to stats, and you go to tests. This is the t-test. I'll leave that up there for a minute. Pretty big p-value. If I had to get 0.35 or whatever. So when we conclude, are we going to reject or fail to reject? Beautiful. Because our p-value is 35 hundredths, which is greater than our level of significance, we fail to reject hope. There is insufficient or there's not enough evidence. And you always have to go back to Hoff. Just if you ever refer back to Hope, you miss it because they think you're accepting the null. So how can we go back to Hoff? There's not enough evidence to conclude what? That the true mean is different or not equal to 8 is different than 8. We wanted the ground alcohol. I think it's a little better with my context about alcohol. Okay. Yeah, and that's what I said before. I said it. Rhonda was her name. Yeah, she did. And she does that every year. There's also a little thing where you can put up movie star pictures of it. It's cute, but yeah, she did. Okay, so that's 31. 32. Let's read it together, and I'm gonna let you work it on your own, because I know you're tired of hearing me, but I want us to agree on what we're doing. So retailers report that the use of cents off coupons is increasing. The proportion of all households that use coupons is 77%. Suppose that this estimate was based on a random sample of 800 households, construct a 99% confidence interval for the true population proportion. So, what are we gonna run? What do you call this? What test are we gonna do? Do what? Yeah, a confidence interval for Z. So let's see if we can get into the calculator and try that. Remember, you have to use, when you get to the proportion thing, you gotta use integers. You can't use 0.77. You gotta find a number for that. And get that muscle memory. Yeah. You're gonna get no muscle memory with and you can do it by hand too. Okay, gotcha. It is good to know the pieces. Okay,
May02 stat test. It's called a one-fault Z interval. Or just a Z interval. Beautiful. We have stats. Now, so X is a success. So 77% of the time you get a success for N. So you're trying to figure out what 77% of 800 is. Because it won't let you do anything but a straight number here. Are you seeing that, sweetheart?
yes, I love doing that. I just do it in that first line. Yeah, and that neat. I like that because you get 616 or whatever for that. Yeah. Remember that when we first started doing it, everybody's just trying to put in 77%
Yeah.
was error. So what did you get?
Well, you did it from Maine. And I think I said it wrong, so you're probably just going by Maine. From the one-fault Z.
Okay.
Yeah, I do that too. Okay, so now X is 16 out of 800. What is it, 95?
No, it is 99.
Beautiful, beautiful.
Call that number up, see if you can compare it. Actually,
0.73 to 0.83.
Lady, will you look at that? Brayden, is that okay for you, sweetheart?
Yes, ma'am.
Okay, now, where's your point estimator at? If this is your lower bound and this is your upper bound, where's your point estimator at? Where's your guess? Halfway between. That is what you said, isn't it? I was hoping so bad. Yes, so it's halfway between those two. And Brianna started doing hers out by hand, and it's just plus or minus your margin of error. Good. Now here, we're wanting to do a test. So if this is a one-prop Z interval, This is a, what is this one look like? This time we're not doing air pool, we're going to have to test, yeah. Hey, do y'all remember how to check our other condition proportions? It has nothing to do with number 30. We're still sinning, but this time we're looking to see if n times p is greater than 10 and n1 minus p is greater than. I don't really care about the equality sign. So I got, our n was 800, our probability was that. So that's greater than 10, because it was like 616, and then 800 times 0.33 is also greater. So all the conditions will have. Very good medicine. Then for the do, we want our critical value, which is our z. Your calculator will give that to you, and then your p is 300s. So p is low this time. So what do we do when p is low? Reject it whole. Since or leave out. Less than. And I'm out of room, but I think we've wrote these so many times since our p-value is less than our level of significance. We reject. There is evidence that the proportion is not equal to, the proportion of people that use coupons is not equal. And I'm going to ask a few of you, no reason in particular, other than I just want to know, Ashley, did the one prop D test come back to you as we worked through it and the conditions?
Yes, sir.
Do you think we've done it enough that if you notice, if you recognize it on the test, it might flow out of your pencil? I mean,
Yeah.
once you get started, I mean, because I don't know if we need to practice more. We did so much of this.
Yeah.
What about end time P? Did you remember did you write even the end time P? Okay, well that's good. That's where I was worried. Okay, so if you need to finish a little bit on your own, explain the relationship between a t-test and a z-test. So I want everybody to think, we're making some connections here. What's the difference between a t-test and a z-test, and we use which one? So let's just make it like a little t-chart. So over here is my t-test. When does that happen? Over here is my z. When does that happen? So I'm going to call on you random after you've had a chance to collect your thoughts. So tell me one thing about a z or a t, and we'll add it. So we get everything we need. Kimberly, tell me something about one of those. Beautiful. I was hoping somebody would say me. Really, if you're doing a t-test, you're pretty sure it's a mean. Now, z-test could be, well, I'll just be quiet. Amy, tell me something about Z and T, a big one, there's a big thing.
Isn't it Z-test for proportion?
Beautiful. Love it. Alright, Lainey, tell me something about Z and T.
T is when you don't know what standard deviation.
T is when you don't know the population standard deviation. So, you know, t-tests are for means, and means where you don't know the population standard deviation. So a Z is for a proportion all the time, or the rare case for a mean when you know population standard deviation. If you do a t-test instead of a z-test, don't worry about it. You're just going to get a little bit different answer. I mean, of course, you know, it's be better, but you'll still get some kind of credit for it. That's beautiful. That's about all I had for Z and T. And we'll do this one more together, then I'll let you have the remainder of the time to work on 35. What is meant by the margin of error in a confidence interval? So go back to your formula sheet. Okay, so right here is my confidence interval. Which piece of that is your margin of error? Absolutely. And is everything that comes after your plus or minus, is that area that we're unsure about. So your margin of error in a confidence interval is your critical value times the standard deviation of your statistic. And what is your critical value? It's your what or your what? Good. It's your Z star or your T star, and we do inverse normal to get those. And then it's the standard deviation of your statistic. Okay, good job. I'm very impressed with what